Good morning, everyone. It is 10 o'clock on the West Coast anyway, but it is about 1 o'clock actually where you are, Caridy. And it is, we're going to be doing open hours today. The focus of today is going to be on Yahoo Access, which is a new product that Yahoo just released. And Caridy and Eugene are here. They're going to go into detail about the just do a high-level overview of the product and talk about some of the YUI parts in there, and spend some time talking about the Mojito framework and how that was all built in there. And I'm going to basically just hand off the reins to them pretty soon because they know what they want to say, and what they have to say is going to be really interesting. So just a quick note about scheduling and other stuff. We just released 360 PR2 yesterday, so it's up on the CDN. So if you want to do, well, actually, please do testing against 360 PR2. It should mark the last release that has new features in it. So this is the one to test to make sure that that if you're going to be upgrading to the latest version, then this is the one to test to make sure that when GA comes out, that only critical little things, or well, there won't be any major bugs getting in your way. So this is the one to be filing bugs on, because we're going to be spending most of the time in Sprint 3 for the PR3 doing a lot more test coverage and some documentation of things, and otherwise just responding to any sort of bugs or regressions that are found in PR2. So please test PR2. Please download it and test it, or point to it from the CDN or on the CDN. And you can see the schedule here for PR3 is July 17th, and targeting for end of July for the official release. So just a couple of, well, maybe like a week or so, week and a half after PR3, we'll be pushing out GA. So after PR3, the space between PR3 and GA is really for last-minute critical bug fixes. So we're not going to be doing a lot of changing of the state of the library at this point. And link from the blog post, there's a list of changes. There are definitely some interesting changes in PR2, and you can check out the history roll-up for those. But I'm not going to spend a lot of time going into that, because there is just way too much interesting stuff to cover with Access. So I'm going to stop sharing at this point, and I'm just going to let Caridy and Eugene take over. So with that, it is your turn. Caridy, you want to step up and introduce yourself and Eugene and Access and what's going on now?
All right, thank you, Luke. We want to talk a little bit about Access, and specifically the pieces from YUI that we use, some architecture decisions, and also we want to touch on Mojito. Today we have Eugene and myself. We work both on this project from probably the very beginning, and let's just jump in. So Access is an application. Is an application that was designed for 3 different screens and potentially expanded into more screens later on. For now, it's desktop, iPad, and iPhone. We wanted to create some sort of browsing experience that is focused on search, since we work on search organization at Yahoo. And for that, basically, we look into this idea of having search as a companion rather than a destination where you go and search for something, you click on a link, you go into a new page, then you go back and keep searching. So we wanted to keep like maintaining the search session and maintaining the search experience between these 3 different devices, and targeting people who use different devices on a daily basis. So for that, we decided to create an application for the App Store for iPhone and iPad. I have the simulator running here. So it's basically a browser. We use WebKit and Safari WebViews under the hood, but the experience of searching is pretty much what we did on top of it. On desktop, since we don't have a browser, what we did was to create some sort of plugin. We'll be talking a little bit about it, but basically it's a way to inject a piece of application or an application into every page that you visit. So we have access to uh, provide this companion experience between those pages. So that's pretty much it. Um, in terms of that's the scope of the project. But in terms of architecture, um, and I will be covering some of them, and Eugene also will be jumping in some of the topics. But basically, from the very beginning, we wanted to do it all web, and that was a, a long time ago. But we look into technology at that moment, and we say, well, we can do this in web. Let's try to do it as a web application. But quickly we realized that some of the pieces that our PMs and our designers wanted to put in place were pretty difficult to do it, specifically in an iPad and an iPhone. So basically what we did was to transition from this mindset of all web to all native and then go back. So at the end, we just want you to give you some of the learning points that we things that we learned during this transition. And basically what we have today has our decision making mechanism and some sort of question that we ask ourselves every time that we want to introduce a new feature and decide if that feature will go native or not. So basically, of course, everyone knows about performance and the stability of an app in terms of user responsiveness. When you do native stuff, and when you do um, web, you have way more flexibility. So for us, it was pretty difficult to decide which pieces will be native or not. So first of all, we decide to we have this application that requires or can be split into pieces, and every piece will have their own specific details and features that we have to implement. And some of that in Access, for example, we have this little piece here that is what we call the search layer. So whenever you start typing or doing something, it will do something for you. And because of that, we wanted to bring almost real-time responses, but at the same time, we want to have the ability to provide um, content that is coming over the wire, and also content that eventually will change, and it will change on a daily basis, and also it will change whenever we have to introduce new features or so. So for us, having the search layer to be basically web, because we want to iterate really fast on that. Like imagine we use different combinations, we want to bucket different features, we want to change really rapidly, adding new type of content that we can introduce in this search layer that produce responses for the user based on the query that they type. Stuff like that make this component like very likely to be web, because you want to have control over it. You want to update that very frequently, which is a little bit different from having this as a native component. You need all the users just to update their application in their iPad and iPhone, stuff like that. So it was pretty tough because also this component here requires a lot of performance related tuning. Like we really want to have a very good performance in terms of scrolling and the filling of the scrolling and stuff like that. So even the detail of just pulling here and having more content behind it. So that kind of stuff is really easy to implement native, but not in the web. So basically, that's what makes us decide to use this component as a web component, and which is a little bit different from other components like this one, which is the bookmark. Bookmark never change. So in general, we the driving forces was of course performance and user responsiveness, but in some cases, we really wanted to have control over the component. And if you want to have control, you have to have it in web, because that's the only way we can really control and update and iterate and release very frequently and change things and pocket test things. So that's the only way you can do it. Um,
Yeah, I
so
suppose you can't really bucket test on an app that you have to update, right?
yeah, you don't have the ability to that today. So yeah, so that's critical for us, especially for big companies. We really wanted to just test new things and drive that through numbers and see which one is better. So in that case, it's really easy just to use web for those. Another important thing is the layout. So in our case, we are targeting users that are trying to search. And when you search, you want to have highlighting, you want to have bolding, you want to have the query, like in every example here. Well, it's very small, but we are highlighting the query that you type. We are doing some sort of layout that's really difficult to do when you use native one. So in terms of laying out and having all the components there that require some sort of um, highlighting or anything like that, is probably better to look into web component, web view that will provide that kind of capability. So that's in terms of trying to decide which one will be native or not. I also mentioned this one because this one is just a bookmark and a read later feature. We really don't change this much. So this is, we know exactly what we want and we don't plan to change this. Maybe we want to make some small changes here and there between releases, but they want to have pinch, they want to have drag and drop here, stuff like that. It's really difficult to implement in a way that it will feel like native to the user. So we decide to delegate that to the native layer. Um, so that's the kind of thinking that we use when we try to decide which one will be web or not. Um, so yeah.
Yeah,
So
that's
other than
interesting. I
that,
like the data points about.
think in our case, we decide to, whenever we have a native component, we have a team that does that. Go ahead.
I was just saying it's nice to get the data points about
Yeah, so we have a
the
team
advantages of
dedicated
each
only for the
technology.
native part.
We seem to have a big delay. Hmm. Okay, just go ahead and keep talking.
I think another smaller
Yeah.
reason why we went with native components for some of these pieces
Right.
has to do with the nature of access. Since it's kind of it's a web browser that uses a web view for each tab, and since an iOS apps only have access to one WebKit instance, we didn't want to go overboard with the number of web views that the application uses for core features like the Omni search bar.
Yeah, that's a good point.
Yeah. So the Omni search bar is this thing that you see here. So you you have to be very responsive now because you have to type really fast. You can type even the URL if you want here. And because of that, um, we wanted to have it in the native layer. And also the way that we distribute this or implement this on web, and we will jump into it right away. But some of these pieces here, we decided to keep it native because they are very likely to be used right away by the user. So there's no this delay of loading this the first time, stuff like that. Um, so yeah, so um, Eugene, can you
So,
jump in and talk about the
so to
web?
summarize, you're saying that the one of the primary choices, the primary deciding factors between choosing between WebView and native is how often you anticipate updating a particular feature, or how much control you want to have over the updating of that feature, the ability to do bucket testing for new features or potential changes, and then separately for the ability to use the ability to have the functionality as close to the machine as possible, that you don't have to, you can avoid latency and other things like that that are particularly gruesome on mobile.
Yeah, exactly. Yeah, so imagine that you open this in your iPad or iPhone, and you start typing and nothing is coming up. We can give you a message. There's an error here. Connection is failing or whatever. Um, what if you don't even have that bar that you can type on? Um, so that's the kind of question that we have in the past. Like, what happens if there is no connection and there is no bar? They cannot type. Can we just display that error? Um, so,
Hmm. So
in a sense,
you're actually sort of prioritizing input to native, and output will either go to WebView or to native based on how much control you anticipate needing over that output. But the input needs to be super snappy. It needs to be responsive. So you don't want to you don't want to delegate that to WebView, is what I'm hearing.
Yep, exactly.
Okay, so I could talk a little about the difference between the native app and the desktop plugin. From the perspective of the search layer, I guess that's where all the suggestions, the drop-down suggestion list, and all the visual results, we call these cards. From the perspective of this component of the app, since the search layer component is completely sandboxed and it doesn't really care about whether the host application is an iOS app or it's just another iframe, like in the case of the desktop plugin. What we did for the desktop version was to mimic the native iOS component using another iframes. And so this omnibar portion right here, where Caridy is mousing over, this is a separate iframe from what's below it, and basically the same messages are being sent from within the search layer to that component, as is in the iOS version. And to the search layer, it doesn't even know, like, who the host application is. So it's like the pieces that are native in the iOS app, we basically just mimic them with these iframe components within the desktop. I think the same goes for the bookmark component, right? Like on the desktop, that's also introduced as an iframe or as a web component, whereas on the iPad application, it's a native component, as Caridy mentioned earlier.
So you have the same bookmarks,
so
and you're just recreating the UI of the bookmark interface in the browser plugin. You're just recreating that interface using web technology because it's where you are anyway.
Exactly.
And being on desktop, you don't have to worry about the responsiveness so much.
Yeah, and since at the end we have these applications split into pieces, and we decide to maintain this API between all these pieces together. To put those pieces together, we have this consistent API between the pieces. It's easy for us just to replace the native one with a web version of it, and it's really easy just to plug that and have it just running. And that's one of the things that we wanted to touch base as well. So why we have these independent pieces and how these pieces work together. And I think that's one of the beauties of the project, because we have all these independent pieces of software that work together in a sense of providing some of the features and providing some of the capabilities in the app. But at the same time, each of these pieces could be easily removed and replaced with a new one. And the way that we did this, one of the reasons was that we have distributed team. So we have people in Beijing office, we have people in US and working from home. We have another team that takes care of the native pieces of the application and so on. and also because we want to bring more people on board and people who can create pieces that could be potentially plugged into the application. That was one of the driving decision of splitting this into pieces and independent pieces that work together at some point. Um, and for that, basically, we create an infrastructure to be able to produce that kind of pieces that you just plug in and they just work. Um, so we will talk a little bit about how we do this, and Eugene will give you a little bit of overview on that as well. But one of the important things of this, from the perspective of the architecture of the application, was that we can have these independent pieces being developed by different people and having a consistent API. And whenever they're ready with plugin, at the same time we can push them into production in a different timeline. So we have the application that could be potentially updated in the App Store. We have an application that represent the search layer here, could be potentially updated every week, and we do it every week. And we can have other components like the bookmark that I showed you before that doesn't change that much. It's a web version of it. We just release it maybe every 2-3 weeks. We make an update on it or something like that. So it's easier for us to move faster in a way that we have people focus on very specific pieces of the application and we can ship it independently instead of having this big monster that you have to maintain and push every few weeks.
Yeah,
Although we
and
have other challenges, like Eugene will be talking a little bit about how you can then control this application and all that. Go ahead.
another huge plus that this gives us, well, breaking the application down into sandbox components, is that we can pretty much try to sandbox memory leaks as well. So I think SearchX or Access, this was the first time a lot of us worked on long-running web applications with the potential of memory leaks over time. And so in the beginning of the project, we decided that we would basically just create the components, individual components when they're needed, and destroy them when they're not needed anymore. So that eliminates, or that makes the problem of memory leaks a lot more manageable. So because that kind of simulates the traditional web page model where you don't really care as much if there's a memory leak on a web page because usually the user will click on a link and go somewhere else. And
That's a very good
regardless of
point.
this, yeah, regardless of this design, the communication layer component that we used for communication between all these components had introduced a memory leak that was causing windows that we already destroyed to hang around in the heap, even though they're supposedly they were detached from the DOM and they were gone. And this was finally fixed as of last week.
So, how much time was spent building up the different pieces? What's the size of the team, and how much time was dedicated to building web views and the web components versus the native app stuff?
Yeah, so so as I mentioned, we have different teams working on different pieces, and it was a learning process because we use a new technology at Yahoo. We use the cocktails platform Mojito. We were pretty much one of the first ones to really use Mojito in the server and the client at the same time. So it was like a learning experience. In terms of front end, we have a very small team in US. We have like 5 engineers and a couple of QA folks. In Beijing, we have um, pretty much the same team, like 4 or 5 engineers, one QA. They work in the bookmark stuff for native and web, 2 different teams. And in the US, we pretty much put together the infrastructure and the search layer. Um, So yeah, so that's pretty much it. The native team, we have few folks there too. They take care of all the native part of the application and all the hassle for getting this out there in the app store and all that. Yeah,
So a team of about, what, 12 to 15 people overall, including
yeah.
PMs and management, that sort of thing.
Well, PM, we have a few dedicated PMs on this. In terms of timeline, yeah, I remember that prototype, the first version for web, uh, more than a year ago, and we started talking about it. Our PM asked, "Can we do a browser? Can we create a browser?" It was pretty tough. So we decided not to do it on web because of all the constraints of creating a browser. But for mobile was easier because of um, um, phone gap style applications. So we have native pieces and we have web components. So it was easy to decide, yeah, let's do it and let's create some sort of browser. Um, but yeah, we spent a few months on it, and we are still um, having a huge pipeline of pieces that we want to introduce, and we want to do it slowly.
So really, this whole thing was conceived and put together in just a matter of months?
No, more than that, almost a
Okay.
year. We
Okay.
almost a year,
This is quite
from
an endeavor for a couple of
yeah,
months. My gosh.
yeah, yeah. And we start like from the very beginning, like since all these runs on cocktails, mojito, we spend almost 2 months just doing performance analysis and seeing how much traffic we can receive and how well Mojito and Manhattan performs. And we will talk a little bit more about in probably in other events, but we spend a lot of time just in preparation for start actually developing the pieces and designing all these pieces.
Yeah, and the cocktails platform was pretty new at the time too, so we spent a lot of time with the cocktails team to get all the kinks out.
It's nice to be in at the early stages and make sure that everything works exactly right for you.
Yeah.
Just ask Dave whenever he's implementing something and it requires something further down, lower level in YUI. You make darn sure that that thing works exactly how it needs to work so that he can get stuff done.
Yeah.
So,
So let's jump into the YUI component.
sure.
All right.
Okay, so I can talk a little bit about the core infrastructure components that we used. Um, for Search Direct, which Caridy worked on mainly, um, they basically separate features. We basically separated features based on extensions. So, so like let's say Search Direct needed some kind of feature. If that feature or that extension appeared like in the rollup, then it's automatically registered and used. So it was essentially existence based. If that extension was there, then it was used. For the search layer, we made it so that we use the plugin infrastructure to be able to plug features into on the client based on the configuration, or maybe I don't think we have this today, but maybe based on client side feature detection, we can decide to include a feature or not. Um, the drawback of doing it with extensions, which I think was more of a design issue, was that features were loaded based on existence as opposed to these configurations or these detections. Another aspect of or another difference between extensions and plugins that we saw was related to race conditions related to the runtime. So when you're building a class using extensions, like you don't need to worry about race conditions since everything's already set up by the time you instantiate. Whereas when you load things using plugins, since the plugin host is already instantiated, by the time you start plugging in features, we needed to implement sort of like a run method to sync things up in the end. Okay, so I guess I could show you a code example here. Plugin. So this is the example for the desktop version where we instantiate the plugin host and then we start plugging in features. And these are all the features that are related to the desktop. And some of the issues that we had with this model, I guess, is some of the plugins would rely on features of other plugins, and then so we would have sort of a race condition where one plugin expected another plugin to already be there, but it wasn't. So we had to implement like a boot method to let everybody know, like, okay, it's time to roll. And I think if we had to do it over again, I prefer the extension-based approach to avoid these race conditions altogether. But instead of just registering or adding on all these extensions, if they're there, take the same approach that we did for the search layer and include the features that we need based on the configuration or feature detection on the client. Let's see. And I could also talk a little bit about the communication layer that was mentioned earlier.
Oh yeah, Caridy sent out a ping actually about getting some testing based on the communication layer. So what was that about? It was something about post message versus the y.cl. Can you describe that a little bit?
So the communication layer is basically just a wrapper around the window.postMessage API. And it gives you some things like some built-in security. The post-message API leaves the security portion up to you, so that you have to check which window a message is coming from, whether or not you're willing to trust it. So this one, so the CL, basically the communication layer, has a handshaking process where it verifies that all incoming messages are from this particular window that you've decided to trust. And it's also it wraps the post message API with like the YUI event target API, so it makes it easier for YUI developers to interact with other applications. So it's almost as easy as communicating with other components using like y.fire and y.on.
Yeah, it's basically a custom event wrapper, so you're just communicating using custom events, which is
and Caridy did some
basically emulating the DOM events or the environment events anyway, so it fits right in.
Yeah, and so
Caridy, I'm sorry, go ahead, Eugene.
Well, no, I was about to mention that Caridy did some performance analysis on post message versus CL.
Right.
And do you want to talk about that?
Yeah. So yeah. So to clarify, Eugene just mentioned some of the pieces, but this is a very complicated schema where you have two documents that you have to keep in sync, and to keep in sync means that we need to make sure that they are all both ready to receive messages, ready to send messages, and of course driving all this communication through a secure channel. So there is a registration process that needs to happen. Who has control over each of the ends of this communication, stuff like that. So we battle a lot to get to this point where we have this infrastructure. We apologize because we don't have it ready for prime time, like to release it as open source in the gallery, mostly because of the timeline. But we are committed to have it there to share with you guys all the features that you can, all the feature that this implementation expose, and also all the things that you can do with it. And we have other bigger plans for that component as well, because it just provide a way to open up a channel and do something in the other end. no matter what that channel means. And it also works in native and web interfacing between our components that are web components and the native one without even knowing that you are actually running on a native application. Our source layer doesn't know about it. So yeah, so we did a lot of analysis on that, like how many messages we can send per second, for example. You have an application that is almost a real-time application. You have to go and basically be able to receive and send send messages between these two components almost real time. Also, whenever we create an application, how much time we need to get that application up and running, how much time the browser requires to just create that web view or maybe that iframe and get ready that iframe so you can start sending and receiving message from it. So in terms of performance, we believe is behaving really well. And it's all on top of post messages, so it's really easy to reuse. And having this sugar layer on top of it for YUI is really easy. Just I can actually show you some examples here. Let me request a control. But yeah, so since we don't have too much time and going back and forward on that, so other components that we really wanted to use, and since this is an application that provides almost real-time responses, we really need to have local storage. We need to have a way for web components to just leverage a local storage in such a way that it doesn't slow down the application. We have been seeing a lot of discussion about local storage lately, like if it is good or not, what can you store there or not. So we spend a considerable amount of time just dealing with that kind of problems. And we also want to share that. Again, we apologize, it's not ready yet, but we wanted to do it. So basically, we have one component extending YUI cache offline component. And what we did was basically create this component we call smart local storage. And what it does is pretty much the same that the local storage implementation in YUI does, but on top of that, it adds some sugar and some performance optimization on top of it. Like for example, I think I have some diagrams over here. So one of the big problems is that we are loading and loading content based on what the user is typing, but we don't know how much of this content we can store locally and for how long we are going to keep it there. So there are some limitation in the current YUI cache offline implementation, like you cannot remove elements from it. What happened with the element get expired? Are you going to clean that up or not? What happened if you release a new version of your application? So you have now a different structure, different way to store data. Are you going to keep that as a legacy, or are you going to maintain the same API just for the sake of keeping the same data there, stuff like that. So we came out with this idea of having a sign off on the local source. So every time that we push a new version of our application to production, a new GUID will be created, and based on that, we sign the local storage. So if there is a new GUID, we know, yeah, the data that we have there is useless. Let's just drop that and move on in the new type of structure. Maybe it's the same, but we don't care. We just want to clean that up. Because when we start using local storage, we ended up having a lot of errors because the local storage was actually getting bigger and bigger with all this content that is no longer needed or is no longer actually valid or stuff like that. So we have this process to just sign that and flush the entries if there is any change in the sign off. Also, another feature that we use in local storage that is not implemented in the basic implementation is the removing entries, and whenever an entry is expired, automatically it's removed from it. Other things is we don't want to read and write to local storage every time, so we pretty much try to do it in a smart way. So we know when a window is trying to write down into local storage, so we pipe it and we notified everyone that this is going to happen. So there is a process of gathering information and slowing down the writing action into disk. to prevent this slowness of a synchronic process writing and reading from this. So we have a lot of on-memory stuff. This is an old diagram, but basically we use white on storage. Even when you have like the application is running on multiple windows, like here, you have a different you have a different window and you're typing on it. How can you feed back that into the other window that has a different instance of SearchX running there? So that kind of sugar on top of the local storage implementation is important for us, because now I'm just typing a new query here. I need to get back and see that a query and even the selected element or whatever is there automatically. So how can we use local storage not only for storing data, but also to provide some sort of communication channel between different pieces? And even in the native layer, if you have two web views and you want to pass information from one to another, how do you do it? Are you going to provide a native layer to do that? Maybe, but then there are some security problems. How can you prevent that other pages or stuff will be trying to push data into the native layer? So having local storage, you are delegating that process into the browser, and the browser knows how to handle that. So yeah, so that kind of stuff we put in.
Are the changes that you put into smart local storage, do you think that makes better sense as a subclass of the cache offline, or the local storage features that are there already in YUI 3, or would it make, do you think that the stuff that you've added on would actually make sense to go into core, into that, into those components directly as updates?
Yeah.
Or maybe a bit of both?
So one of the big yeah, I think it's a little bit of both, because, for example, we test how much data can you read and write at the same time and stuff like that. So in local storage, for example, we have entries for every item that you try to store there. In our implementation, we have a single entry, and it's just a giant JSON structure that we dump and read from. So we don't have multiple entries for it. That's a little bit of a change in terms of how you handle that. So basically, you have this Prax implementation that does all the logic that local storage is doing today, but doing it in memory, and then you have a separate process just to dump that into local storage and read it from it. So I think it's a little bit of both. We have to talk about it, and we probably have to come up with some ideas of how we are going to provide this sort of features or way to plug this into the original implementation. So that's about local storage. And other things that we did was scroll view, and this is one of the big pieces. How we use local scroll view for native, not for native, but for the web pieces that runs in iPad and iPhone and also in desktop. And Eugene will give you a little bit of overview on that.
Yeah, so we were able to basically reuse the scroll view paginator for the pagination that we do inside the search layer. I think credit goes to Caridy for that one. We basically hooked into the pagination event. And the way that scroll view paginator works is that it moves to the next card. It increments by 1. And in our case, we have multiple cards in one page. So I guess we sort of needed to redefine what a page was for our application. So whenever the paginate event occurs, we hook into that and we calculate how many cards are actually visible right now in the scroll view. And then instead of returning 1, which is the way that the scroll view paginator is implemented, we return the index of that card instead. So I think we were able to avoid writing a lot of custom code just to do this, and we were able to reuse most of scroll view paginator when we implemented this pagination that we have. We also did a lot of optimizations for the scroll view. in our case for this search layer. Initially, we had it so that we would get the markup for each card from the server, and we would just inject it into the DOM. And this was actually pretty good in terms of performance, but we needed a lot more control over each card. Like, we needed to be able to see each card as an individual card instead of in memory, instead of touching the DOM and checking what each card was. So today we have two types of cards. We have the visual cards that you can see right now, and we also have Bing result cards. And so now we have an in-memory representation of the search layer, and we touch the DOM only when we absolutely need to. So essentially, we moved the source of truth of what cards are available in the application from the DOM into an in-memory representation of the card list. So in the future, now that we have this available, we can do awesome things like injecting sponsored results into the list at low performance cost. Were there any other things that we optimized here, Caridy?
Yeah, so I think that's pretty much it. A couple of days ago, I don't know if Ryan is in the call, but yeah, Ryan posted this, which is similar implementation of what we did. So we figured out that having a lot of NTLIs in the DOM is not that bad in terms of memory and implementation. It doesn't consume that much memory. It doesn't slow down the application, especially when you do it for iPad and iPhone. You have these memory constraints. We figured out that having 1,000 elites there, empty elites, don't do much. But if those elites have acceleration and also have some sort of content on it, like images or just text or highlighting words or whatever, it considerable slow down the application and eventually crash. So we have to have this optimization of having only what is really needed. And it is a little bit uh, um, uh, of impacting the user experience, because sometimes when you scroll really fast, and it happens here and also happens in Access. Let me open here this one. Probably when you scroll a lot fast, you might get into this blank element that eventually will be populated, or not populated because we already have it in memory. We just display for the user. So you have to compromise on that. Like PMs and designers, yeah, you want to have all these images there every single time that you scroll, so the user don't see this black spot. But there's no way you can achieve that. This is a web view, and even in actual native, you have more memory and stuff, but still you have 1,000 cars, and every car is just this. For example, you have 1,000 of them because the user is just a crazy scrolling dude. You will reach a limit. So we have to really remove those pieces from it and control whenever we have to update this or not. So we spent a lot of time on this optimization, and Satyan helped on that as well. But yeah, I think those are pretty much the things that we changed in the scroll view, and hopefully we can share that. We have to talk to Ryan to see what he's going to do with the implementation I did. It's really nice. Was looking at it to see what we can do to get to the point where we can really provide at the YUI level component that allow you to define these deltas that you want to keep in the DOM, and those that you will not keep in the DOM, how you're going to update it and all that. Other than that, other interesting things that we did was the polling thing. Like when you pull here, you stop here, you click, it goes back. So we basically add few events on top of the YUI scroll view. Actually, in the source, we still have a fork version of the original YUI. Eventually, we will get back to the main trunk. But we did a little bit of changes on important events that we want to know about the scroll view state. And one of them was the pooling, basically just providing a way to notify whenever there is a pooling in one of the ends, and how big is the pooling, what in terms of pixels, how much are you pulling, so we can display this for you, and then masking that, so whenever you interact with it, we close it, stuff like that. Which I
So
think
is that
are
implemented as a
a little bit.
subclass or a class extension?
No, it's actually an event on the fork version that we have today. So it's internally, whenever there is a pull event, there is a routine there, but there's no way to hook into it. So we basically fork and then create this new event on top of it. So hopefully we can bring that back into the original YUI implementation to give you the ability to look into those kind of events, because it's
Yeah.
impossible today. So other than that, I think we try to avoid making any changes there or triggering any loading process if the scroll view is still moving. We do it whenever we feel like you finish the dragging, so you release your finger from it, or you stop the animation, or the animation just ends. Stuff like that, to try to avoid like having multiple stuff going on at the same time. Otherwise, you get this flickering thing. But that's just optimization. You have to spend time on doing it. Other than that, I think Scrubview is really good. We are still thinking about using the native scroll view, since it is now supported for vertical and horizontal both. So just using the regular CSS scroll and removing the styles and just having a regular native scroll there. The problem is that you still need to know what is the position of that scroll, what happened, how can you control the pulling on one of the ends, stuff like that. So we're still um, um, thinking about it, but I think the performance of the YUI scroll view is really good at this point, especially in iOS 5 and hopefully in 6 as well. 4, we still have some little problem here and there, but I think it's just memory and little optimization that we have to do. So yeah, so I think that's pretty much in terms of components that we extend from YUI. We have other pieces that are like specific for the application, but that's about it. I think we have a little bit of time. We can jump into the Mojito stuff. I think this is the important part. Fortunately, we don't have too much time, but
Yeah.
um,
Yeah, I think we might actually have to we might have to postpone that if you're willing to come back and talk about the Mojito stuff in a separate open hours. And we could, I suspect that there's plenty of content in there that could fill a whole hour just by itself if you're up for that. And we'd love to have you back on.
yeah,
So, but yeah, it is about time for us to wrap up. Sorry we got started a couple minutes late, but I'm glad that a bunch of people showed up, and I appreciate having you guys on to help give us a little demo about what it is. I'm really interested in the potential for the modifications and the updates and performance enhancements that you put into the existing components. That's pretty exciting stuff. I'm also really excited about the communication layer, hopefully making it into the gallery sooner than later. I know that there was some other folks that were interested in that as well. I like the feedback that about the decision-making process for where to fork between native, hybrid, and web technology. I thought there were some really great takeaways in there. And leave us with a picture of YUI. That's nice. But so I guess for now, let's leave it at that. And if you guys have any other questions, then I think you have Caridy and Eugene's Twitter handles, and you can add comments in the blog post. You can find us in the forums and at YUI Library on Twitter, and of course in IRC, in the YUI channel on IRC, and we'll get these guys back again for another open hours where we can focus on the Mojito side of things for those of you that are out there that want to see some of the guts of that, and a nice reference implementation for sure. It's looking really sweet, and so really impressive work, you guys. It's really awesome, and I love all of the findings that you get from real-world implementation and performance that programmers. Nice. All right, so let's close it
So
up. Oh, yeah, do you have
yeah, let's
any parting messages?
yeah, Bayjax. I think we are going to do an open Bayjax in the 25th, in 2 weeks from now. Uh, uh, and
That's
we are
right.
going to cover way more than what we did today. So we want to have more ground representations, and hopefully you guys can join us there. And about Mojito, yeah, we have a few bullets here we want to cover, but hopefully next week or whenever you guys have time.
Yeah, we'll make time for you guys. Definitely. Awesome. So I guess for that we'll close it out, and we will see you guys very soon. And so Caridy and Eugene, thanks for joining us, and Rafael and Fabian and Juan, also on the Access team. We're also in the chat hanging out with us. Thanks to you guys for coming in as well. And anybody else that joined into the chat that was helping out with this, thank you guys as well. Really awesome work. And so until next week, I guess we'll see you on the interwebs.